So in this video, I'm going to show you how to find the circumcenter by hand. First, we're going to do it on GeoGebra. So it says, step 1, construct 3 perpendicular bisectors. So we can just click on perpendicular bisector and then click on each side. We only really need 2 of them to find the intersection. So then we can click here and we can have GeoGebra tell us the values of this point. So show value. So there we go. It's very easy on GeoGebra. 1.54.1, but how do we get that by hand? Well, we need to do the steps we did for the last section just 2 times to get the equations of 2 of these bisectors. So I'm going to hide one of them. It doesn't matter which one. Let's just hide this one because we only want to find 2. So first step, let's hide this, is to get the midpoint. Find the midpoint of each side. Okay, so to find the midpoint of this side, we do the x coordinates of a plus b, divide by 2. That looks kind of bad. So that would be 4 over 2, which is 2. Okay, and then we do the y coordinates. Add them up, divide by 2. So that's 12 over 2, which is 6. So the coordinates of this midpoint are 2 and 6. Okay, and then let's find the midpoint of the other side. So we're going to use A and C. So that's going to be -5 plus -3 divided by 2, which is -8 over 2, which is -4. Okay, and then the y coordinate is going to be 8 plus -2, so 8 minus 2 divided by 2. So that's 6 over 2, which is 3. So coordinates of this point are -4 and 3. Okay, now we need to find the slope of each side. So the slope of segment AB, all right, slope of AB is, now we do the slope formula. So take the y's and subtract. So 8 minus 4, put those on the top. And the x's and subtract. -5 minus 9. So that's going to be 4 over -14. 4 over -14. And we're going to want to simplify that. Cut those in half. 2 over -7. Okay, and then we want to find the slope of AC. So I'll write slope AC. So that's going to be the y coordinates, subtract. So 8 minus -2 is going to be 8 plus 2. And then -5 minus -3 is going to be -5 plus 3. So that's going to give us 10 over -2, which is -5. Okay. Now, to get the slopes of the perpendicular lines, this is where we do the negative reciprocal. So negative reciprocal of this would be 7 over -2. But we want negative reciprocal, so the whole thing has to be positive. Okay, so that means the slope of this perpendicular line is 7 over 2. And then the slope of this perpendicular line, we would just take the reciprocal of -5 over 1, so it's going to be positive 1 over 5. Okay, and you can tell by this line, it's a positive line. Both of these are positive. So it makes sense. Okay, now that we have our slopes, we need to find the y-intercepts. And those are a little bit hard to see on the graph. Here's one y-intercept. This one has a y-intercept all the way down here. So we're going to have to find those by hand. So using the slope, let's find this y-intercept first. So we use y equals, now the slope of the perpendicular is 7 over 2. x, and then we put plus b because we don't know that. And now we have to plug in the midpoint. The midpoint of that perpendicular bisector is 2 and 6. So we plug in 6 for y and 2 for x, and we solve. 6 equals, these 2's are going to cancel out, so we just get 7 plus b. So that means that y-intercept is -1. And you can kind of tell. Okay, so the equation for that perpendicular bisector then is y equals 7 over 2 x minus 1. Okay, almost there. Now we need to get the equation of the other perpendicular bisector. So doing the same steps, we need the slope. So let's do it over here. Y equals 1/5 x plus b. And we plug in that midpoint. So y is 3. 1/5 times -4 plus b. And then we solve that. Now this is a little bit harder. It's going to look like it's going to be a fraction, because 1/5 times -4 is -4/5. And then we've still got this 3 on the other side, so we're going to have to add 4/5 to both sides. Might make it easier if we change this to a decimal. 4/5 is -0.8, so we add that to the other side and we get 3.8 equals b. Okay, so the equation of this line is y equals 1/5 x plus 3.8. Okay, now how do we get this? We did a lot of work so far and we haven't found it yet. We have to set these two equations equal to each other and solve for x. That's the last step. So we take 1/5 x plus 3.8 and set it equal to 7/2 x minus 1. So we're going to need another page for that. Let me open up a whiteboard. Okay, and let's write those equations down. 1/5 x plus 3.8, and we set that equal to 7/2 x minus 1. 7/2 x minus 1. Okay, now if we solve this for x, that's going to tell us the x coordinate of the circumcenter. So get the x's on one side and the numbers on the other. Now this is going to be a little bit tricky because we're dealing with decimals and fractions. So we could change 1/5 to be 0.2. Use your calculator to do that. 7/2 is 3.5. So this is one case I think decimals are going to be better. So now let's subtract 0.2x on both sides and add 1 on both sides. So this cancels out, and we have 4.8 equals 3.3x. We divide by 3.3 on both sides, and then we could get out our calculator. 4.8 divided by 3.3 is 1.45 repeating. 1.45 repeating. So let's go back and check our GeoGebra. Whoops. The x coordinate they put is just 1.5, and that's because they are rounding. 1.45 repeating would be rounded to 1.5. Okay, and then to get the other coordinate, what happened to my screen? To get the y coordinate, we just need to plug in 1.5 into one of these equations, either one, to get the y coordinate. So let's do that. Let's do 1.5. Let's go back to this page. Let's just say this is about 1.5. And we can plug it into either one of these. I'll just do 3.5 times 1.5 minus 1. Okay, and 3.5 times 1.5 is 5.25. And then minus 1 is 4.25. And so then when we go back to GeoGebra, they put 4.1. So, that seems a bit off to me because we should round that to 4.3 if we're in the business of rounding. So let's see what GeoGebra is doing. If we change the settings and we go out a few more decimal places. Okay. Yeah, so 1.4545, that was right. And this should be 4.09, so that's why they put 4.1. Let's double check my work here. So this is one place where rounding can get us in trouble. We didn't do anything wrong, but if we plug in 1.4545 and multiply it by 3.5, we're not going to get 5.25. We're going to get 3.5 times 1.454545. Just do a bunch of 4.5s repeating. We're going to get 5.09 repeating. And then when we subtract 1, we end up with 4.09, which is about 4.1. So just a good example of rounding and the errors that can come with that.